Hey again, it's Benjamin Freeman Wilson with another Langium tutorial. So in this one, we're going to talk about taking the generator that we were working on before that produces JSON output from our AST, and we're going to jump right into actually generating drawing commands. So without further ado, let's get right into it. One of the things we want to change right at the bat is to rename this function. Say, let's call it generate JSON, just to be a little bit clearer. And then in our main, that should be updated accordingly. And yep, it is. Okay, good. So what we're going to do here is take this generate target. We'll just call it generate JSON now. What we're going to do is actually add an additional target. And this one's going to be called generate commands. Okay, let's go ahead and duplicate this just to be quick. And let's call this generate commands. Generate commands. Great. So then we want to generate commands from our model. So this will actually take given file name, load it, parse it, and then generate commands off of it. We've got a little error here. Let's correct that. Right. Okay, we need to pick a name. Okay, so let's do generate commands. And here, let's call this CLI generate commands to avoid the conflict, and then CLI generate action as well. CLI generate action commands, okay. All right, now we can call this generate commands. Okay, excellent. Okay, we're still gonna do the same pattern as well here. Just gonna change it a little bit so we just spit it out to the console. And we're just gonna inline that. Yeah, okay. We could shorten the one above as well if you wanted to, but I'm just gonna leave it alone for now. Okay, so now we have two different CLI endpoints without actually doing anything else. Let's see if we build. And let's test this. So let's actually see what the CLI does. Okay, perfect. Okay, we got generate JSON and generate commands, both registered. The generate commands little cutoff below there, but it's there. Okay, so let's get into the generator. Okay, so for generate commands. Okay, so I've copied this in. This is what we want to generate as an example. Take a program like this and generate something that looks like this. And to do that, we need to traverse the AST. So we're going to start by generating statements. So we have a function here that generates statements, generates from statements. This will allow us to traverse what is contained in each statement. We also want to generate off of defs as well. But really what we're going to do is we don't really care about the defs at the high level. We just care if there's a statement that invokes a def or a definition. So if there's a definition that's never invoked, then it has no impact on the generated output, same as a function that is never called. So we don't actually need to traverse the top level defs. We just have to see if the statement invokes it. On our statements, we have the following 5 different built-ins that we need to consider. The pen, move, macro, for, and color statement. So we need a case for each of these. So now I just did a series of branches with the base case here. Let's add just to be thorough, just error, missing handling for some statement, yeah, just in case. And don't forget your imports as well. This one is wrong. Yep. Okay, now let's start filling in these statements. First statement is pen. It's one of the easier ones. Basically, have two conditions we have to factor in our two possible states. Either we're filling with the pen up or pen down statement, but they're both in the same kind of category. So let's add the handling. So here's the implementation. We need to change the type because we're just returning an array of objects, which is inherently very vague. So let's just be object or undefined. Yeah, and there'll be some cases we won't have a result. So we're gonna just keep that object for now, even though it's really big, just so we can proceed. Okay, so the rest of it. Oh, also important to keep in mind that here, we need to update the type, return type accordingly. Yeah. Okay, now for the rest of the statements, it's important to know that we actually need to write an expression evaluator. So we need to actually define a type for an environment that will be evaluating expressions within. And we need to actually then define this expression evaluator that takes this expression and an environment and produces a value. Now the semantic domain for MiniLogo in this context for expressions is just numbers. So it's fairly easy. We just have to worry about that one return type. So now let's go ahead and implement the expression evaluator. Okay, so I've gone ahead and written out the expression evaluator, a lot of code, but we're going to go through case by case together. Okay, a little more compressed. And one of the things to note is I added this type above, it's just an alias to a map. This is basically our environment to store references and the values that they produce, so we can look them up quickly. Okay. Now in the expression evaluator, the first case is literal, which is trivial. Next case is a cross-ref, and we actually use our environment. So we just look up the reference name in the environment, and if it exists, retrieve the value. If it doesn't, we just throw, because that shouldn't happen. It's just a fallback just in case the reference doesn't work with it. We should not get to this case. You could handle this a little differently and just fail if the reference doesn't exist, but there are many ways to kind of go about that. Okay, now the binary expression case. So quick note about this, there's an error right here actually. And initially when I was writing this, I thought this was a mistake. So I regenerated Langium, the Langium grammar, to get the AST types again, but realized that actually the mistake is in the grammar itself. It's a very, very small mistake. So in for binary expression type, I have E1 and E2 here. For the multiple rule, it's E1 and E1. It's supposed to be E2, so that was the mistake. Pretty bad one. But then I went ahead and regenerated off of it, and then after it, I believe it should be all good. This is some of the other errors, but that's just because we're not finished. Okay, but that corrects that. That's what I figured the error was. Okay. If you've been following this tutorial, you probably have the same mistake, by the way, so just make sure to correct that. Okay, and let's do a quick switch over the operator. And depending on what that operator is, we go ahead and perform that expression directly and return its value. So we just one-to-one mapping here, just fallback default. Again, just in case. Now for negation, fairly simple. Just negate the result of another expression in the current environment. For grouped expression, it just allows us to evaluate the expression in the context of itself. So we just take the expression and the existing environment and evaluate it. And then always good to have a sanity check, just in case. You never know, just in case you miss something. Okay, now that we are back with our evaluator, we need to actually perform evaluation on these expressions that are contained within these statements correctly. So one of the things we want to do is to actually evaluate all the statements at the top level. We need the environment at the top level, right, to start with. Let's just move our type up just to make it a little bit neat. Yeah. Okay. And then we're going to be using this environment to then help with the evaluations. Okay, so let's start out. Let's just stub these out with empty arrays. Okay, and the first one is for move. Move is fairly simple. The command is just literally move, and it's just X and Y are both evaluated. So, but the type we're going to be using here, which we should be changing this again, it's generic object type. Really shouldn't be using this. But in this case, we're just going to have the command property indicates the type of command, and then the following properties will actually dictate, will be dictated by that command type. So we should change that later. Okay, but for this one, yeah, we have X and Y are both expressions that are evaluated in the context of the current environment. And then for macros a little more verbose. This statement has a definition cross-reference, so we need to get the def and the cross-reference to it. And we can cast it, but yeah, we don't. No, actually, we do need to do the cast just in case. So we're making an assumption that the cross-ref has been resolved correctly, and assuming that if it wasn't caught correctly, would have gotten an error earlier on. It's casting just to avoid a double check. We want to copy the existing environment, and this is important because for this semantics, for this implementation of MiniLogo, we want to be able to say that the environment can be changed inside the invocation of an actual macro. However, we want to say that if we then exit that macro, that the existing environment remains unchanged. So localized changes do not propagate outside of their scopes. And so this is important for scoping reasons because we have the same name of say a parameter is being passed in and it takes an X or something, and there's another parameter named X that's inside the function, matches something outside, you could actually mutate it, kind of violates the scope. So we want to actually do it this way. Okay, so we want to actually, to do this, we evaluate these arguments independently and then copy them over to kind of avoid polluting our existing environment. It's just to avoid conflicts with existing names. And again, the common case, if you had like X defined outside and you had, well, a function calling a function or macro calling a macro with X and then X again, you might mutate that second X. So you got to avoid that. Okay, so I made a small change here to add an environment so that we can actually pass it in so that we can actually carry on our pre-existing environment and evaluate those statements based on the context. And now for these for function, this one's not too bad, but this one's actually pretty straightforward. We set up the start and end conditions first by evaluating them. And then we prepare with an empty array of results and we create a loop environment. Every time we execute the loop, we update the loop environment by taking the statement name and then changing it. This is basically our counter. And then actually taking the results and accumulating them through the invocation. So the effect of this is that if we have a for loop that draws like a square, and we want to run it 5 times, you would collect the results of drawing 5 squares. So this is important, and we return those collected results. Now the color statement, this one's kind of nice. It's kind of 2 subcases. Either the command is either a color that is followed by a literal hex value color that's such a statement color, and we do not see the color property there. Well, if we don't see the color property there, we assume we only have the RGB property, so we're just assuming those are present, and then we're actually composing an object with RG and B components set respectively. Now this reflects the choice in the grammar for color. Here, where you can see it's either RGB or color ID or color hex. It could be a literal color or a hex. We're assuming that both cases will be handled kind of effectively the same, which is pretty convenient in the context of JavaScript, for example, the text green or the 0x or hex value can be passed as well, and they'll both work. So that's handy there. And then last time, let's add a quick sanity check just to make sure we don't miss a statement or something like that. Okay, so now our statement generation logic is actually done. This is actually correct, but we still have one more problem. And this is evident. I'll build again. So we still have this generic object type. This makes sense because we didn't have any statements to start with. We didn't know we were returning, so let's go ahead and redress it. Right, yeah, this is the base case. If we don't have any statements, we have to return something. Let's do that. Then we should be happy. But we still want to address that type. Okay, we can run this, but let's do one more thing first. And in general, we should try and change this type later because to be more specific will guide us in our implementation, and it'll also give us more certainty in the code we've written later because this object is just basically too general. We really should be more specific. And so let's just do that actually. So let's just take type and let's declare. So we can write this a number of ways. I'm gonna make a type for each of these generated statements. Make a type for each of them. Let's say it's a pen or move or a macro. And actually, all right, it's actually, we don't care about macros, although macros do have semantic meaning that don't actually translate into NT one-to-one unit. They're one-to-many. They break down and are turned into maybe nothing, or a macro with an empty body that evaluates and produces no effect. But in general, it's going to be a series of statements. So we don't actually need to put this in our type because we're not going to be generating macros. And the same for for, by the way, for the same reason. But we definitely want color. So these are the 3 controlling instances that we want in this type. And then let's define the pen. And now what's neat about this is just looking at what we have here, we just define the command prompt. So you just pen up or pen down. Okay, and then type move. which is just move. And we know that it has an X and a Y, both of them as a type number. And then we have color. Now color is a little bit weirder because it's two different cases, kind of. It can be an actual hex or string. It could be a hex, hex, string, or RGB components. So let's just do the string case or the RGB case to keep it simple. So we just do color string or color RGB. Let's do type color string. Actually, I'll do a little trick here in a little bit, but let's just say the color string is just the prop here for this type, and then type color RGB. We can put the components for R, which is a number. Let's say number. Let's check. And yeah, because the semantic domain will be numbers, so we can match with that. RGB will be numbers then. Great. Okay, now you may have noticed, if you're paying attention, that there's no command defined here for color, and color needs a command. So we need to actually define a type intersection here to add the command prop with color. Okay, so we don't have to write it twice. Yep. Okay, and then we'll go ahead and add some helpful descriptions. Okay, I just updated these, and I also realized that I wrote object here as the type, which is kind of shadows the built-in object. So let's not have that. Let's change this all to generated command now. Okay, and the best part is now that if we have an error, we're going to see it. Object, yep, it's because we missed that type there. Okay, that's good. Let's look at this really quickly. Okay, let's double check. I believe what's happening. Oops. Yeah, I did the type intersection between the first alternative. I wanted to do both of them, so let's just group them. So we're being more explicit now by saying that we have the property command and the union of any of these types. So we actually get command prop on both of them. Okay. Now let's go ahead and build. And you know what the heck, we'll do generate too, just to see. Okay, cool. Okay. So now we have set up our generator for commands. So let's just try and run this thing, see what happens. Okay, so I think I have a case here. The previous generator, that is valid. Let's check. Check commands. Okay. Convenient that it's adjusted the correct one now. The wrong command. And lo and behold, here we go. And now we have command pen down. But that's definitely not correct, so let's double check this. Yeah, we have a pen down and a pen up. We shouldn't just have the one. So let's double check and see if we can find the bug in the generator. Well, I found the error. It was really obvious, actually, when I was returning all these commands. The first command pen up was the only one that we were actually getting. So that was a bit of a small oopsie. But I went ahead and changed this to actually be an array of commands that is incrementally increased by just pushing the next generated command onto that stack. And I went ahead and rebuilt it and checked it, but let's just build it again to prove. And there we go. There's our pen down, 1010, and our pen up. Cool. So we are actually generating commands. So although these are simple commands, and you could change them if you want, there's no need for them to be exactly this form. You could, take creative liberty here. You could see that maybe there's no need to put pen up at the end or something, et cetera, et cetera. But the point being is that you can take this very simplified set of instructions and you can feed it into another program. It could be a TypeScript program, could be Python, could be Java, blah, 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 et cetera. And you could actually perform drawing using these commands. You could actually drive a simple drawing machine from this. I mean, you could even drive a physical piece of hardware if you wanted to, and you could draw with that. It's just a matter of how you handle these commands and how you dispatch them. This is quite powerful. And now that we have this here, we would kind of like to think that the generator is more or less in a good spot. We could make improvements and changes, but I'm pretty happy with this as is for now. So with that being said, We'll then move on to the next section about generating an actual VS Code extension. So as you've noticed before, when I open a MiniLogo program, I actually get syntax highlighting, and I get support, and that's really quite nice. So this is what you would expect, right, for your custom language. And this is actually not very hard with Langium. So you just build a VSIX extension, and in the next tutorial, we'll tell you how to do just that. But in the meantime, thanks for watching. Hope you learned a lot about Langium for this tutorial, and we'll catch you in the next one.